This video is going to go over how to graph quadratics when they're in vertex form. So when we say vertex form, imagine a problem over here. Basically, you can get your vertex from these two numbers. This first number, the -3, is going to lie. So you do the opposite of that. And then the +1 tells the truth, so it would just be 1. So 3, 1 would be my vertex there. So that's kind of what we're talking about when we say vertex form. But let's go ahead and look at what the parent function looks like. The parent function for a quadratic, I'm going to use these coordinates, -1, 0, 1, 1, 0, 1. So it's like these coordinates right here. And it's kind of similar to absolute value in terms of its shape, but instead of a V shape, it's more of a U shape. So it looks something like that. That's not my best drawing, but that's okay. But the important takeaway here is these coordinates right here are what I'm going to be using to graph these later problems. And in terms of the actual vertex of this thing, it's this middle coordinate. So let's go ahead and look at some examples. It says graph each transformation. First of all, find your HK, your vertex, which is 4, 3, and put a dot there. All right, now you're going to want to make a quick table. And you want to use those parent function coordinates from before. Okay, now you have to apply each transformation. So you should already kind of have a decent idea of what we're doing. But if not, basically anything inside the parentheses, like this -4, is lying to you. So you would do the opposite, so +4, and it's going to affect my x values. So I'm going to do +4 on these x values. All right, and anything outside of the parentheses, like this, +3, tells the truth. So I'm going to actually add 3, and it's going to affect my y values this time. So I'm going to add 3 to my y values. Okay, now when you actually go to graph it, you're going to use the outermost x's and the outermost y's as like coordinates. So this first one, 3, 4. And then just do a U shape off of that. And that's how you would graph it. Okay, let's look at this next one. Get your vertex. Your vertex here is at -3, -2. Go ahead and go put a dot there. Okay, now you're going to have to do your XY table. So go ahead and copy those parent function coordinates. All right, when you apply these transformations, it needs to go in kind of like a left to right order. So the first one here would be this negative. It's outside, so it's going to be affecting my y values. And it's just a times -1. It's just a reflection. So this first negative is a times -1 on my y values. Okay. The next one would be this +3. It's inside, so it affects my x values, and it's lying to me, so I'm going to -3. All right, and then this last one's the -2 at the end. That's affecting my y values. And when you apply it, now you're applying it to these new y values. So I'm going to -2 on all of these numbers. And when you graph it, just make sure to use the outermost numbers as your xy coordinates. So from this vertex, which was at -3, -2, I now have a point at -4, -3. Then, of course, -3, -2 is the vertex. And then -2, -3 is my last point. Then just make a U shape. Like that. And by the way, wherever these transformations, after you apply them, wherever the middle one ends up, that's your vertex. So you can also get it there. All right, let's look at this next one. Find your vertex. It's at 1, -6. Put a dot there. All right, now make your XY table. Use those same parent function coordinates. All right, remember, go left to right when applying these transformations. So this 2 goes first. It's outside of the parentheses, so it affects my y values, and it tells the truth. So I'm just going to multiply by 2 on all of these numbers. Okay, the next one would be the -1. So this next one's the -1 here. It's inside, so it's affecting my x values. And I do the opposite, which is +1. Then the last one's this -6. It's outside, so it affects my y values. And I do what it says, which is -6. All right, now I have the coordinates and I'm ready to graph this. So 0, -4. The middle one, 1, -6, like I just told you, that's your vertex. And then 2, -4. So it looks something like this. Okay, this next one, find your vertex, -5, 2. Put a dot there. All right, parent function coordinates, same as before. All right, now this first transformation, you can either do it as 2 different transformations, or you can do it all in one in terms of writing it in your table. So like I could do times -1, and then I could do times 3. That would work. But the easiest way to do it is just to do it all in one move. So just times by -3. The next one would be this +5. It's inside, so do the opposite, which is -5, and it's affecting my x values. That's not right. There we go. Okay, and then this last one's the +2. It's affecting my y values. Graph it using the outermost points. Nothing to it. Okay. Next up, they give me the graph and they want me to write an equation in vertex form. So to do this, the first thing you should do is identify your vertex, which here it's at -3, -4. So I know my equation is going to look something like this. You kind of just write that equation where it would make your vertex work. Just remember the x is the opposite here. So instead of -3, you should have written +3. But you're not done once you've done this. You still have to go find this a value right here. And the way you're going to do this is you're going to pick any coordinate. So I'm going to use this one right here. You could use any coordinate though. on this graph, you just pick one. So this one's at -1, 0. This is an x, y coordinate. So that means I can plug it in for my x and for my y and solve for a. So this is what I'm talking about. The f of x means y, basically. So my y value is 0 equals a parentheses. Now this x value that I've chosen to use is -1, so that's going to go right here. So it looks like -1 plus 3 squared minus 4. All right, now just do a little bit of algebra and solve this for the letter A. So -1 plus 3 is 2, and then that's going to get squared. So this is going to look like 0 equals A times that 2 squared was 4 minus 4. So really you could rewrite this as 0 equals 4A minus 4. Solve for A, so add 4 to both sides. You get 4 equals 4A. I'm running out of room, that's okay. Divide at the end. You get A equals 1. That's not your answer though. Your answer is the actual equation. So go back to this where it's written in blue and just change that letter A to whatever you just got. So in this case, 1. So it would look like this. And this is my actual answer. So basically, identify your vertex and start setting up your equation. Then choose any coordinate and solve for the letter A. So let's look at this next one. My vertex is at 0, -3. So write a quadratic that kind of would make that your vertex. You could put x minus 0, or you could just put x. Okay, so this is my start of my equation here. Now I'm going to choose any coordinate because I have a letter A here that I have to go find. I'm going to choose any coordinate. Let's choose this one, 1, -5. That is an xy value that I can plug into for my y here and my x here. So go ahead and plug it in. Y value -5 equals A. That's what I'm solving for. My x value here was 1. All right, now just go solve this a little bit. 1 squared is 1. So this part's going to become like 1A. Add 3. I got A equals -2. So remember, that's not your answer though. Your answer would be to go back to this original equation and copy it and then just fill in your A value. Like that. Okay. These last ones, when they want you to write it in standard form, basically standard form is would look something like this, like ax squared plus bx plus c. That's what they want you to do. So in order to do this, basically you're going to have to FOIL these things out. And FOIL stands for first, outside, inside, last. All right. So I'm on this first one. I'm going to do the x minus 3 squared part first. X minus 3 squared is essentially like if you wrote x minus 3 twice. All right, now in terms of how to FOIL this, the f of the FOIL is the first number times the first number. So x times x is x squared. Now the outside, inside, the O and the I, is your outermost and your innermost multiplied times each other. So the outermost is x times -3, which is -3x. The innermost is -3 times x, which is minus 3x. And then I have the L. The L stands for last. It's your last number times your last number. Just watch your negative signs when you do the L. So this is -3 times -3, which makes +9. Now you'll have to combine like terms in the middle. So this is really x squared minus 6x plus 9. That's just this x minus 3 squared part. You still have to handle the +1. So remember there was a +1 here. So when it's all said and done, my answer would be x squared minus 6x plus, I'm combining the 9 and the 1 to make +10, like that. Okay, the next one's a little trickier because they put an a value there. So you're going to have to FOIL this out, and then you're going to have to distribute a -3. So let me show you what I mean by this. Go ahead and focus on the FOIL part. So that's x plus 4 squared. X plus 4 times x plus 4. The first makes x squared. The outside makes 4x. The inside makes 4x. And the last makes 4 times 4, which is 16. Combine your like terms in the middle. This part becomes x squared plus 8x plus 16. So I can rewrite this equation, -3. I just FOILed that x plus 4 squared out and got x squared plus 8x plus 16. And then the +2 at the end. Now here's what I'm talking about. You have to take this -3 and you're going to have to distribute it to all of these things. So it's going to look like this: -3x squared minus 24x minus 48, and then that +2 at the end. Now just go and combine your like terms here at the end to get your answer. So my answer here would be -3x squared minus 24x minus 46, like that. Okay, so that's how you graph these quadratics when they're in vertex form, and that's how you write the equation in vertex form from a graph, and then also that's how you FOIL these things out to get it to standard form. So I hope this video helped.